G'day people, welcome to another YouTube video. Today I'm showing what I did to my SDRplay software defined radio. For those of you that have already got one, you probably already know that it comes in a plastic case, which for all intents and purposes works fine for most things, but the plastic case does actually allow some RF interference to enter the case and bypass the antenna circuit, and the SDR receiver itself also radiates a fair amount of junk as well, so ideally it should be in a metal box. So this is what I'm showing here is a project that I did to put my SDRplay in a metal box. I'll give you a look at the box. First up, the box is a die-cast alloy box. I think they're commonly known as Eddystone boxes. Should be able to pick one up at pretty much any electronic supply place. This particular one here is 95 millimeters wide by 120 millimeters long, and it's about 35 millimeters high. For people in America, I'll give you the what do we got? We got 3 5/8 wide. We got a bit over 4.5 long, and 1 3/8 high, approximately anyway. This rule is hard to read. So what I've done here, I'll open it up in a minute, but in the meantime I'll show you the outside. What I've done is to mount the actual board, I countersunk 4 holes. Now I didn't use countersunk screws, I didn't have any at the time, so I will be replacing these with countersunk so that they sit flush with the bottom. The case has got 4 screws there that keep the case together. SMA connector, the original one that come with the SDRplay, mounted on the front there. On the back I've mounted the boards flush up against the side of the case, and there's the USB connector. Also made an additional hole there for an LED, which was going to have a red LED there just to show that it's getting 5 volts from the USB port. I haven't decided whether I'm going to put the 5 volt indicator LED in there, or possibly put a band switch. When I say a band switch, a band filter switch. I had intentions of putting another additional filter in there, just to help a little bit at the lower frequencies, particularly below the broadcast band. Anyway, so that's the external look. We'll open it up and have a look inside, so you'll get an idea of what I've done and how I did it, in case you want to do the same thing yourself. Take the 4 screws out. This particular case is from a place called J-Car, which is an electronics parts supplier here in Australia, and I believe in New Zealand. I think you might even have one in the States these days, I'm not sure. Now I don't know why, but all of their Eddystone die-cast boxes, the first time you put the screws in there, the holes feel like they haven't been tapped with the right size tap. Extremely hard and tiresome to get the screws in the first time around. Once you've got them in there once and taken them out, the second time you put them in, they actually go in quite easily. Alright, so there's the SDRplay board. You hopefully see that. You see how I've mounted it. I've mounted it so that the USB socket is flush with the actual fitting, as you can see there. I've also added an additional ground from this screw to the 2 grounding points, soldered points on that USB socket, just to give it a little bit of, make sure it's getting a proper ground. Also the 4 holes on the board, I had to open them up, make them a little bit bigger. As standard, they're quite small, and it's hard to find screws that actually fit that size hole. So, but when you do that, I advise you be very, very careful. The board has got a lot of tiny little surface mount delicate parts on the top side which you can't see here in this view, but you have to be very, very careful not to damage the board when you're drilling out the holes to make them a little bit bigger. Now, I'll try and explain this. I can pull the board off and show you exactly how I did this, but I'd rather do it without pulling the board out, save me a bit of time. And as I say, set the board flat on the lid, component side up, which is the opposite of what you're seeing here. Made sure the board was centered, left, right on the actual lid, and made sure that the front of the USB socket was flush with the front of the lid, like it is there. Held it down tightly with my finger, and with a pen marked the four, with a texter, fine point texter, marked the 4 screw holes. I took the lid outside, drilled the 4 holes, countersunk the 4 holes, drill them and countersunk them, and that gives you the actual pattern of the 4 bolt holes. Now, once you've done that, you get the board and you turn it up with the component side down, which is how it is there at the moment. I put some screws through the board. As you can see, they go through the board, and some spaces there. I found some spaces there which just happen to be the right size, and sat the board on top of the screws as you see there, with this just resting on the little lip on the lid. Got a sharp pencil and marked the actual area of the lip that the USB socket was resting against. Removed the board with a file. I filed down the lip just wide enough to accept the actual USB socket, and then sat that back inside. Adjust the height of your spaces, so you might have to, whatever spaces you can find, you might have to play around. These ones just happen to be exactly the right size. If yours are not exactly the right size, you may have to improvise and put some washers under it to build up the height. You've got to get the height just right so that when you bolt the board down, that is sitting in the the USB socket sitting in the cutout that you provided on the lip, but you're not actually bending anything. Everything's sitting there nicely. Okay, once you've got the board sitting in there and you've cut the recess and everything looks great there, you then sit the board and the lid, everything together on top, and you move it forward until the USB socket hits the front, and you just get a pencil, mark out the actual shape of the USB socket, and then proceed to file that off with a file or cutter or whatever you've got. Usually you find these boxes, they file very, very easily. If you've got a square file, it's very, very easy to file that down. And that's it. Once you've done that, you can see this USB socket sits flush there. SMA connector on the back. You get your 4 screws that come with the box, and you screw them in like so. So there it is, SDRplay in a lightweight alloy enclosure. Okay, a little bit of let's have a little bit of a talk about the SDRplay. I got this receiver about 2 weeks ago, roughly 2 or 3 weeks ago, and I have had a bit of a play with it. I would say that for the price, I paid $250 approximately here in Australia for it. If you buy them online, I think you can get them for even less than $200 if you look around. But anyway, $250 in Australia. For the price, it's not a bad unit. It's not as good as a dedicated, say, HF SDR. You know, that might cost you $800 or $900 for just the HF band. It's not gonna beat that by any stroke of the imagination. But you know, considering it covers from 100 kilohertz to 2 gigahertz, receive performance is pretty good for the price. It's extremely sensitive. It's probably the most sensitive SDR that I've ever had. In fact, I think sometimes it's maybe a little bit too sensitive. So forever fiddling with the IF gain and preamp settings on the computer. But it's yeah, for the price. I mean, you have to accept that it's not going to be a super SDR, but it's fairly good. Anyway, thanks for watching again, and please subscribe, thumbs up, thumbs down, whatever you feel like doing. The main thing is please subscribe, because I do intend to make more and more videos of projects and stuff. So if you're into electronics, into radio in particular, or into all sorts of weird and wonderful things like VLF or ELF reception, subscribe. I do have plans on making quite a few other videos